Welcome to Containerized Conversations. I'm your co-host, Jesse Caffarelli, and with me,
Is the other co-host, Josh Warhurst. How you doing, Jesse?
I'm doing great, Josh. And today's topic is CI/CD. But I think it would be great to first start off by explaining the definition. Do you want to take it?
Sure. So CI/CD is one of these terms that's thrown around a lot. There's going to be CEOs and CTOs and people that say, hey, we need CI/CD. That's the hot new thing, right? Without understanding really what it is. CI/CD is an acronym, like everything in the tech world. There has to be an acronym to make it simple. And CI/CD stands for continuous integration slash, sometimes the slash is in there, continuous integration slash continuous deployment or continuous delivery. But let's start with continuous integration. What's continuous integration?
Continuous integration is where you as a developer make a commit into your repo and it gets picked up automatically by some sort of system that runs its tests, and your code change that you made gets a pass or fail. You can merge it in, and then it gets merged into a mainline branch, and in the mainline branch, it runs even more tests. And if it passes, it builds. Now, in even bigger organizations, there would be some cross-team testing that would then test all of their edge cases all together with your services and all the other ones. And if it passes or fails, it all gets packaged up. And that is continuous integration. The continuous part, every commit, it happens continuously over and over again. So you're getting your feedback as fast as possible. And integration, you're testing your stuff with other people's stuff.
And what's the benefit to all this added testing? Why can't you just have separate branches that you're all working off of and then a release 6 months down the line that just takes all those branches and makes it into something?
You know, probably for our listeners, if you're not fully into DevOps yet, you haven't entered into this huge change, you probably have some sort of integration testing already. You probably have some team that's doing your integration testing. You're doing your code changes. So the big change for you in this model is the continuous part. It gives you your feedback a lot faster. And what a lot of companies find, and this is proven through Forrester, is that if you can catch your bugs quickly and as early as possible, as close to when you've developed that code, you can fix it a lot faster. If you think about it, it kind of makes sense, you know, especially if you're working in a big code base where you're working on like a bunch of different things, and some part of it's authentication, some part of it is data transformation, some part of it is some sort of tracking system. If you work on this piece of a feature and then you send it off and then you go work on something else, and then 6 months later somebody comes back to you and says there's a bug, you're completely forgot what you even worked on that 6 months ago, never mind where in that code base it is. Now, vice versa, imagine you submitted your code and you're about to go work on your next ticket when you get an alert saying you just broke something. Now, all of a sudden, you're like, I literally just submitted that. Oh, it's here. Oh, I know what it is right off the top of your head. You can fix it a lot faster. When people say continuous integration enables the developers to make changes faster and fix problems faster, that's what they mean. It's a lot easier to fix a problem when it's fresh in your mind, and it's a lot harder to fix it when it's 6 months ago.
Yeah, you're talking about reducing context switching, which is that people, while they're still in the thick of it, while they're still thinking about it, they're actually getting the feedback. And sometimes the feedback is not quite instant, but it's still more instant than 6 months later. I find that out of the whole acronym of CI/CD, this is probably the one that nobody has any complaints about.
I think where a lot of the arguments come in is when you start talking about the specifics. So like unit testing.
Mm-hmm.
Do you measure code coverage? And do you require a specific minimum code coverage? Now, I think you have some experience with that. What's your thoughts on that?
Gosh, code coverage, as like a gut feel, I think 60% feels good. There's a lot of times where it actually doesn't make sense to test. If your code has a lot of APIs, for instance, and you built a system out where the APIs are automatically built in and tested, they might not come through the code coverage, but you've designed around that, then you don't need to be testing all that. A lot of embedded stuff where you require actual hardware, some of that You can do that outside of the code coverage tool with actual integration tests that might be much more reliable.
I actually want to ask you two very specific questions with your experience. One, as a platform engineer building a platform, how much code coverage should there be?
Good questions. How much code coverage do you want? I wish I could give somebody a really hard, clear number. I think more so than the number, making sure that the important functions are covered is
Yeah.
much more important. You could have 20% code coverage, and if it's covering the most critical pieces of your infrastructure, that matters. The other thing is sometimes the code coverage, you can have something and it hits that line of code, right? And you get the coverage. It's nice and
Yeah.
green, right? But it's not really testing it. Like a unit test where it ran through that line of code, now it passes the code coverage tool, but you didn't really test this.
So I guess the hot question is did you measure code coverage in the platform? Was there a code coverage?
We did, because Go has
Yeah.
a really nice tool to generate code coverage,
Really?
right?
Okay.
So
Yeah.
I love it. I love it.
Yeah.
It was one of those nice tools where it would pull up all your code and it would show green lines and red lines for whether it was covered or not. It would actually come up in your web browser.
Okay, so you guys would generate an actual HTML report. That's really cool. And then this would be inside your CI/CD pipeline.
Yes. I loved it actually as a developer to go and say, "Hey, are we actually testing this piece?" We had it break. We saw that after the app restarted that it was getting stuck on this line. Is this actually being tested? Oh, okay, maybe our tests were weak here, right? I
Yeah,
think
yeah.
there's a lot of value there. The high level piece is that it's more important that you're testing the right code and that you're testing that fully than testing everything.
Now, to the second question, in robotics specifically, as an embedded developer, can you do continuous integration? What does it look like? And is it a little bit different than in software?
The hardest part about hardware, that's why they call it hardware, is the fact that you need the actual piece of equipment there to do stuff. So you can actually hook up a pipeline to SSH into a specific machine
Yeah,
and have it run through things. Now, that machine
yeah,
has to be hooked up correctly,
yeah,
and that's very expensive. You can imagine you have this robot that costs $15,000. As an example, it's sitting around being used just to run these tests. And hey, you want to spin this wheel? Well, you better be sure that wheel, nobody's touching it, right? So there's a lot of weird problems about doing that. So people will go and do things like create mocks.
Mhm.
They'll go and say, hey, this is a mock of hardware. It's not actual hardware. You have to then build out the mocks. It's almost like doing simulations. And yes, those can be really valuable, but it can be really hard to replace the actual physical hardware with a mock test suite. And it takes a lot of time,
Yeah,
but you're trading costs. The
yeah,
hardware costs a lot of money and it can be dangerous. And then you might have bottlenecks. You have 14 developers and you have one machine. Well, now everybody's waiting for that machine to be free so they can run their tests. You might find that somebody actually physically running tests on these machines might be faster.
yeah.
But one of the things I love about pipelines is that they're incredibly consistent. They do the same thing each time to the extent that you can get that right. You want to try to get your CI/CD pipelines as good as possible.
And I could imagine a world where if you are an embedded developer and you're on a team of embedded developers, that you would have like 15 embedded boards. And each embedded board is hooked up to a Raspberry Pi through the serial connection. And that Raspberry Pi is running your GitLab agent of sorts. And there's a one-to-one mapping. So you essentially have your fleet of testing, basically. And you could test your embedded software. The only limitation to your point is if your board needs to be physically hooked up to a magnetic sensor that's not on there, you can't do your testing, right?
We had literally a copy of the boards that were in the machine. So we didn't have the casing, we didn't have the wheels and stuff, right? But we did have the motors and we did have everything. And it was all on this big tray. We made a bunch of these. I think we made like 8 or 10 of them. And they were all basically equivalent. And you could send commands, right? We would run the unit tests on the physical hardware. It wasn't really a bot, but it was close enough. And it did have things like a magnetic sensor, and it had a magnet below it, and it was making sure that we are actually getting signals correctly. But then you also run into the issue where people said, hey, every time it hits board 6, it's failing this one test. Right? But it passes on board 7. And so you now have this effort of maintaining all of these boards. You can't just do it like in some cloud thing where they're detecting issues. You actually have to maintain your boards and figure out with monitoring if your boards are failing.
Yeah.
So there is a lot of problems that can be presented, but I think they're problems worth fixing. If somebody is starting a robotics company today and they say, do we need CI/CD? I would say yes. Get started as early as possible, especially on the CI part. Right.
For sure. And we haven't even moved to CD yet. Let's move there. You kind of said continuous deployment and continuous delivery almost in the same breath as if it's the same thing. But I'm going to be very adamant that a lot of companies get this wrong, and they should not. Continuous delivery is and should be a completely different stage from continuous deployment. It naturally comes when you're doing software development. So going back to our analogy as the developer, you've done all of your integration testings all the way up. Now you're ready to actually package it. The delivery part of your pipeline would be your piece of software has been packaged into some sort of release package and then pushed to some sort of artifact server. Docker Hub, Artifactory is a very popular one, ECR in AWS. Somewhere where your package is packaged up and pushed, that would be your continuous delivery section of your pipeline. Now, why is that super important? A lot of like SREs or DevOps will actually fall into a trap where they don't version their packages for things like Terraform, for things like GitOps. This is a big reason why I've always had a huge issue with GitOps. That line between delivery and deployment get kind of smudged to the point where you find that teams are just deploying the mainline branch and there is no versioning. Whatever was in main at that time when you deployed your package, that's what's deployed to this environment. And the reason why that's an issue, so let's say you have 20 different environments. How do you know what version of main is on each one of those environments? Because if I hit the button to deploy to this environment, everything looks great, and then I went and deployed to this environment, but in that 10 minutes that I checked everything, someone committed something, and then I went and deployed to this other environment. Now everything's broken. Why is it broken? I deployed it here, it was fine. Oh, someone snuck a commit in, right? So it's very important. Make sure your delivery and your deployment pipelines are very separated.
When people talk about CI/CD, right? It actually is one of those acronyms where I feel like the order is built in. You have to do the CI first, and then you do the continuous delivery, which is a process of taking that artifact that you've built and tested that's going into like mainline. You're doing that, and then you're sending it out to some place, and then that can be used later as part of deployment. What I wish that we had is an acronym that was like CI/CD/CD.
Yeah. Well, no, there is an acronym. They do call that, but I almost think you should take it a step further. The acronym should be CI/CD/CD, 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 CI, because you're doing CI/CD/CD, and that's like your dev environment, CI/CD/CD to staging, CI/CD/CD to prod. So you're actually doing the cycle, but you were doing it in small iterative cycles all the way up until your customer gets it. So it should just be CI/CD infinite or CI/CD star, right? Just recursive.
I'm being sold.
All right, I'm coining the term CI/CD recursive.
Yes, CI/CD calls itself.
Yeah.
So we haven't even talked about continuous deployment.
Yeah.
So we've talked about continuous integration. So in a perfect world, everything that you have is being integration tested, unit tested before it gets in the code and after it gets into the code. Continuous delivery, you're building the artifacts and ideally storing them in some place. Sometimes the place that is building is also the storage location. Sometimes it's in a different server. That's all up to what makes sense with your organization. Continuous deployment is actually another stage. It's the stage where your code that you just built in mainline is now getting deployed out to a production site, for
Yeah.
instance.
Yeah.
The base version of continuous deployment is that you're sending your code immediately, the one that has been tested ideally with your CI pipeline. It's being pushed out to some server. Now, it doesn't need to be production. The gold standard that a lot of companies want to move towards is deploying it out to production. But that requires such test rigor and also a test and production environment that's stable. For instance, there's a lot of deployment techniques. Say maybe you deploy it out to one user, and then two, and then three, and then 10, and 200.
Yep.
But the fact is, you're not scheduling this. Continuous deployment is all about it being automatically done and kicked off without the need of scheduling, which can do a lot to reduce the overhead of a release. And more importantly, it does a lot to make sure that every release is as small and bite-sized as it needs to be. We've both seen the problems with having changes from the past 2, 3, 4 months all get packaged into a release, and then a bug happens, and people, when it's finally released, even though it's been tested the entire time, the moment it gets out to production, there's a bug that was never discovered before, and people are trying to figure out how it happened. And they're saying, which change in the past 4 months led to this incident, right? And now everybody's jogging their memory. They're context switching. They're trying to remember what happened. They're looking through the giant commit history. Instead of saying, hey, this change happened today in production. We did have an issue, but we know it can only be the change that happened today, or maybe the change that happened yesterday compounded with today. But you're limiting your blast radius by doing continuous deployment.
Yeah. So many companies I work at say, yeah, we have CI/CD. But oh yeah, we have someone hit the deployment button. That's not a big deal. Oh, we have deployment days. We have code freezes. Then you don't have CI/CD. You might have CI, but you don't have CD. Maybe you have continuous delivery, but you don't have continuous deployment. Now, I do think there are companies where continuous deployment don't make sense. In our interview with you, we talked about how platform engineering at your company was trying to enable the customer to do the actual upgrades. You were continuously delivering packages to your customer, and whether or not it got deployed was really up to the end user. It's the iPhone experience. You don't have to upgrade if you don't want to, but if you do, it's there. And so in Apple's perspective, in your, experience, continuous delivery was just fine, because the point is you guys weren't doing the actual deployments.
Yeah, we were thinking that the device is the user's device. And so they should be the guardian of their own device, and they should decide when it should be updated. We want to provide them the update and the mechanism, but it's their choice. And that will lead to issues. You will get issues where people say, hey, there's a security vulnerability. And you're like, we fixed that 2 years ago. Yeah, but they didn't take the update. You do run into those issues sometimes, but that can be part of your model. On the other hand, you might run a website like, say, Netflix, where you're not actually using your device, you're interfacing with their device. On a lot of web applications where they kind of own the platform is a much better place to do continuous deployment.
Exactly.
Because if you have a security issue, you want to deploy that out to your devices as fast as possible.
Yeah.
And then when other people access it, they're not worrying about, is this actually the latest version or not?
Yeah.
It depends on your product. It depends on your ownership model to decide, do you actually need continuous deployment?
Yeah. So this is the section where we'll move into what I was really excited about, which is hot tips. Okay. So you're on board, you're like, okay, yes, we need to do this, but how do you implement this? And what are some pitfalls? One thing I would say for continuous integration is you will be using a tool that's doing this testing, that's doing this packaging, that's doing the building to automate it. Now, my first tip, make sure whatever tool you're using, you can reproduce it locally. Don't use some crazy templating solution that some vendor tool is offering that you can only run in that specific vendor tool. that you can't do locally. Don't make your Terraform state stores so overly complex to generate that you need to run 20 different scripts to do it. Make sure whatever you're doing, you can run locally. It is really important because when the build fails, you want to make sure you can get that build passing as fast as possible. And the only way to do that is to be able to reproduce the issue locally, especially when you first start. It's just going to say exit code 1. It's not going to even tell you why. It's just going to say exit code 1. You're going to have to run it locally. And if it takes you an hour to set up your local environment to match your Jenkins environment or what have you to be able to do it, you're going to get frustrated and go, why did I do CI/CD? So that's my first very hot tip.
I'll give you an anecdote, which is one of the problems that I've occasionally had is I will go and work with somebody else's CI/CD pipeline, and I'll run their code. They say, hey, the code just broke. And I'll come in and I'll say, I can help you with that.
Yeah.
That doesn't seem too bad, right? I'll go and I'll run the thing and it fails in the pipeline. And I say, well, why is it failing? And I'll run the pipeline again and it fails. And then I'm thinking I could make a tiny change and run the pipeline again. It's not actually good for creating a fast fix. But figuring out how to get your environment to match the pipeline and then being able to do it locally, because locally is always the fastest way to get something done.
Yeah. So my second hot tip is pretty close to that, which is do not become lazy and allow your tool to do your testing for you. Now, I'm not saying go do manual testing in production or staging or what have you, but I'm talking about as a developer, when you first start creating that piece of code, or as an infrastructure engineer, when you first start creating that Terraform, don't be lazy. Don't just commit it and allow your CI/CD tool to do your testing for you. Problem 1 leads into problem 2. When I come into some of these teams and the junior developers, it takes 5 hours to do a change to Terraform. And when I start digging into why, it's because they're waiting 10 minutes to get their feedback from the pipeline. And so they'll do one small commit, wait 10 minutes, do another small commit, wait 10 minutes. Yep. Hot tip number 2. When you fix hot tip number 1, you can do it locally. Make sure you do it locally before you commit it.
Mm-hmm. Yeah, there is definitely a coffee break moment that happens for some people where they say, hey, my pipeline, this is going to take 10 minutes, so I'll go up and grab a coffee, right? Or I'll go and go to the bathroom. And that's fine sometimes. But yes, when it becomes a habit, when you find that you've spent the day doing tiny commits, waiting for the pipeline, tiny commits, waiting for the pipeline, when setting it up locally would have saved you 3 hours.
And that's the thing. I'm guilty of it. There's definitely times I've been part of code repos where to set it up locally is so freaking much that you're like, I'm just not doing this. And so you look at my commit history, it's like, okay, yep, that broke. I don't even know. There's like 20 commits and it's just small code changes, but just I'm talking to myself, honestly, not to any of my audience members. Do yourself a favor. Figure out how to get it running locally. Figure it out, and then you'll just have such a better time in the future.
Yeah, but it's hard when you're an SRE and you're working on a new repo that you've never touched before, and they're saying, hey, fix this for me. And that can be really hard because you say, is this actually something I'm going to have to deal with a lot in the future?
Yeah.
Kind of comes down to gut feel, but my gut feeling at this point is that treat everything like you're going to have to deal with it again in the future. If you're first time to the repo and it's going to take you some time, and yes, they want that fixed right away, but it's better long-term for you to go and get your local environment ready for every single repo the first time than building it 40 times, waiting for the CI/CD to do the right thing for you.
Yep. Yeah, and then my hot tip 3 moves into continuous deployment. This is my last hot tip. There's 3 in 1. A detection on failure, automated rollback strategy, 0 downtime deployment. You don't need to have all 3 of those, but if you want to make continuous deployment successful, you need to have detection on failure of deployment, and you need to then trigger a rollback, or you need to make sure that you have 0 downtime deployments so that your customers aren't hitting this.
I mean, couldn't you have your customers be the detection mechanism?
Yeah. You don't want that. That is how continuous deployment implementations fail and companies refuse. And they'll go back to manual, and it's very bad. But if you can recover fast from a failure, if you can deploy and there's a problem and you can roll back and you can even detect, just implement one of them first. It will lead to the next one, and you'll be more practice at it and it'll feel really good. But it is kind of important to have zero downtime deployments when you introduce continuous deployments.
Jesse, gut feeling, if you had to rate those three, so having your rollback strategy, having detection failure, having zero downtime, how would you rate those three? What's the most important? Or are
So,
they
I mean,
equally important?
so like in order for you to even have a rollback strategy, you need a way to detect when it fails. I guess arguably you could have it automated to roll back, but be a manual trigger when someone says it. Okay, yeah. Realistically though, it depends on the application. And so you need to know the uptime of your application, because there are some applications I've worked with that are like Kafka consumers. They consume events and they do something with those events. Now, if those consumers went down for 10 minutes, 15 minutes, not a big deal. The downstream events weren't getting triggered. Some data processing might slow down a little bit, but production wouldn't stop. Like, it's not something like a website, a front end. If the front end went down, your customers are instantly complaining. You have some leeway when a consumer fails. So in that situation, zero downtime deployment is almost not necessary at all. But what is necessary is detecting the consumer lag, detecting when those consumers do stop, and then being able to roll back before that queue becomes crazy big. So if that queue doesn't build up super fast, then the first thing is really just detection. That is probably the biggest important thing. And then come up with a rollback strategy afterwards. So I would say probably that. But in other situations, let's say you have a website design where you need like 29s of uptime, right? You need 99.9999% uptime. Then the first thing you need to do is figure out how to do your deployments without any outage, because you're never going to be able to continuously deploy if your customers are screaming the second your website goes down.
Is the easiest way to do a zero downtime deployment through things like load balancing?
Kubernetes is probably the simplest way to do any sort of zero downtime deployment, but it also comes down to application development as well. Because if you develop a stateful application, then even if it's in Kubernetes, you're not going to be able to allow Kubernetes to do its zero downtime deployments. So, it's really important to develop either stateless applications or at the very least an application that you can bring down, and as you signal it bringing down, it saves its state somewhere so that it can go down and come back without having any sort of data outage or take a long time to come back up. Then that's really good. And then yes, to your point, if you can't do that, then you do it through networking, right?
Yeah.
You do a blue-green deployment. You have the old version running while you bring up the new version. And then once the new version's up and you make sure everything's good, then you bring down the old version. So yeah, there are strategies and they get more and more complicated depending on your use case. You try to avoid those as much as possible. But honestly, if you're a big company like Netflix, then we're actually talking about taking it a step further, and you can do rolling deployments to specific regions, so only specific customers in specific countries go out, right? And so technically that's not an outage. If all of Japan can't watch Netflix, it's technically not a full outage.
That sounds like an outage to me.
If most of your Netflix customers are in the United States, then your outage is only 10%. You have only a 10% outage. Arguably, that's not a full outage, right?
Somehow I don't think Netflix will see it this way, but they might. They might. And I think you might find that works for you, right? If you find that your application is used mostly in the United States, and then you find that Costa Rica went down, they might be your canary release, right? Yes, there are a lot of different strategies, but I think all three of those tips are very good strategies. And again, your application doesn't necessarily need continuous deployment. Figure out if that makes sense for your app, but don't feel beholden to the fact that sometimes people think CI/CD includes the deployment. And if you want to be the best DevOps team in the world, you need continuous deployment. Figure out what makes sense for your app.
For sure.
I think that's it.
Yeah, I think that was a great conversation. And I think we definitely touched on a lot of subjects with great hot tips for our audience out there.
I hope everybody goes and updates their CI/CD pipelines or starts building them from the beginning.
Exactly. And that was our containerized conversation. You have a good night.